Welcome to my presentation on radar. Myself, Anand Selvakarthik, Assistant Professor, Department of ECE, Hindustan College of Engineering and Technology. Overview of my presentation is radio detection and ranging, radar functions, time delay ranging, superposition of waves, followed by radar range equation. First, radar definition. Radio detection and ranging is abbreviated as radar. It is basically it is of three types. One is bistatic, monostatic, and quasi-monostatic. If the receiver and transmitter are located at some different locations, it is called as bistatic. Here you can see at different locations. And monostatic, if they are locating at the same position, this if this antenna is acting as a transmitter, the other is acting as a receiver, it is called as monostatic. And if the transmitter is locating at this particular point and if the receiver's antenna is located at this direction, it is called as quasi-monostatic since it is fixed at the same location but at different direction. So this is called quasi-monostatic and this is monostatic and this is bistatic. So this is how the radars are classified. Next, radar function. Based on the function of the complexity, that is cost and size of radar get increases for normal radar functions. The normal radar functions are find the distance, speed, and the direction, angular direction. These are all the normal radar functions. The next level is signature analysis and inverse scattering. That consists of parameters like target size, target shape, moving parts, and material composition. For example, this is your transmitting antenna, and this is what the target. If I want to find the distance and the velocity and angular distance, it comes under normal radar function. If I want to if I want to know the size of the target, shape, and in which direction it is coming, and the material composition, it comes under signature analysis. That type of radar will be economically, it will be expensive. It is more expensive, and most of the type of radars will be used in the military purpose by the government by the concerned governments. Next, time delay ranging. Target range is the fundamental quantity measured by most of the radars by means of a round trip travel time of a pulse. So this is what the transmitted pulse. It will be transmitted towards the surface, I mean the target, and again it is getting reflected back to the receiver. So actual pulse will be in this shape. Once it is getting reflected, the shape of the pulse will get changed based on the different reasons. We'll be knowing in the upcoming slides why the shape of the pulse is getting changed. The next is classification by waveforms. So if we want to design a radar, first we have to fix the waveform. I mean the type of waveform what we are using, that is based on our application. Continuous wave, it is frequency modulated continuous wave for minimum applications, that is a civilian application. Next is pulsed, and in that pulse it is non-coherent and coherent. And in coherent, you're having low pulse repetition, medium pulse repetition, and high pulse repetition. This low to medium, it is used for MTA, that is moving target indicator. The next is pulse Doppler. If there is any change in the frequency, if it encounters any Doppler effect, we have to prefer this PRF. Or else, if it is keep on moving, we have to choose this low frequency. I mean low PRF. The repetition in the sense, this is what my radar antenna, and the generated waveforms will be like this. Like it will be keep on sending the waves. So repetition in the sense, this is what the repetition of, this is first wave, this is second, this is 3, this is 4, and this is 5. With equal interval of time, the waveforms will be getting, I mean the pulses are getting transmitted in the atmosphere. Like this, waveforms will be. So this is what the meaning of pulse repetition frequency, the gap between the two waves. Superposition of wave. As I said before, once the signal is getting transmitted towards the target, it has to be reflected back to the receiver. Once if it is getting reflected, it will be it is not the actual signal. Somehow it will get hit from the ground, or else by means of any obstacles and something else. So this we will not be getting the actual signal. How the signal is getting the pulses are getting affected by means of interference, or else by means of some ground bounds multipass that can be misinterpreted as multiple targets in that location. So this is nothing but superposition of base. That is the combination of two different frequencies combined, and that will be received by the receiving antenna. Next is radar range equation. This is the one of the fundamental parameter of radar. It is composed of transmitted power, received power. We are going to calculate the received power, and for that we have to use transmit power, antenna gain, as well as receiver antenna gain, and the radar cross section. That is in terms of meter square. Antenna patterns: the fan beam is used for 2D search, whereas the pencil beam is used for 3D search. So this is the radar cross section. This is nothing but the area that covers by the transmitted signal. So transmitted signal will be covering some area like this. If this area is about 20, sorry, if this area is about 100 meters square, it is about the fighter aircraft, and if it is 1, it is defined as a creeping and traveling waves. If it is 0.1, we can assume it as a birds, and if it is 0.001, we can assume that the target is the insects. So these are all the fundamental formulas associated with radar cross section. Thanks for watching my presentation. That is basic concepts on radar. Thank you.